Hello there. So this is our third part of the solid principle series. So we did single responsibility principle, we did open closed principle. It was quite a bit lengthier video, but I have explained everything in detail. So this code base that you're seeing on the screen is also done in those two parts of the series. Now in the third part, we are going to learn about Liskov substitution principle of L of solid. So see, Liskov substitution principle is a bit confusing for beginners because it's trickier even for the developers to think about what it means actually. But I'll show you an example of what this actually means. Even for me, initially when I tried to learn this, it was a bit trickier and I felt it was a bit confusing. But how I understood it, I'll try to explain it in a similar way. See, what this principle says is, it says that your base class, for example, you have a base class and a subclass, and it says that your subclass should be able to substitute your base class without having any unexpected or unusual behavior. It doesn't talk about errors or anything else, okay? Errors are completely different. We are trying to write a better code or managed code, right? So it's not a coding tutorial, it's a code management tutorial. Understand this, okay? You might be saying, okay, without using LSP or Liskov principle, whatever you say, the code still works. You might say that. Of course it will work. Without using single responsibility principle, without using open close principle, your code will work and it will work the same way. But what we are learning here is to better manage the code. And in Liskov principle, the principle has clearly stated that your subclass should able to substitute your base class without causing any unexpected or unusual behavior. Right now, with whatever we have created, it doesn't behave in an unexpected behavior. So this already follows Liskov principle. So we can see this through one example. For that example, please look very carefully, okay? This is very simple, but this might be a bit confusing. That's why I'm very concerned about you guys to not make you guys confused, and I want you guys to learn this in a way that you never forget it, never ever. So I want this to be embedded into your brain. So I'll show you a simple example, so this might help you understand it better. So I'll create a vector. See, vector, and this takes a data type of tax. See, this takes a data type of tax address. All right, so I'll call this tax. See, now our base class, this is a base class, right? And I'll comment this out for now. See, I have this vector which takes the address of our base class. So if I say tax dot pushback and then add new and tax, let's say was close. Now this works fine. Now this vector, what does it expect? It expects a type tax address, right? This expects, this tax expects, what does it expect? It expects a address of type tax, which is our base class, and what our Liskov principle says, our subclass should be able to substitute this base class without causing any unexpected behavior. This code already follows it, and to make you better understand this, I have to write a wrong code, or let's say a code that doesn't follow the Liskov principle, to make you understand how a different code will look. The code that doesn't follow the Liskov will look like. Okay, so if I say, I'll just copy this, paste it here, and push back, and I want to give origin tax here. See, now I'm passing a different class. This is a different class, right? Even though it's a subclass, but it's a different class. It's a different type. but still it will work just fine, even though it is asking for a type task, but we are passing what? Address of the type urgent task. It will work just fine. Let's display this here instead of task. Again, display. I'll just display task, which will take a vector. Okay, we already have a vector. Okay, task. So if I run this, see, what do we have here? It says was closed, incomplete, urgent, was closed, incomplete. Working fine. There is no unexpected behavior. It works just like how it is supposed to work, right? Even though it is asking for tasks, there is no any errors, there is no leaking or anything. We have memory created here, so I might also want to delete this. So for I'm using for each loop, so tasks, let's say auto. This is not necessary. I'm just trying to, you know, always remember to delete the values of whatever you have created dynamically. Always like remember to delete this object. This is not part of the tutorial, but just a reminder, you know, like whenever you create an object dynamically, make sure you delete it. So for every task in tsk task, which is this vector, I will say delete task. All right, so it is working fine, right? So what will a code that violates Liskov principle will look like? Let's say I'll create another subclass just like urgent task, and I'll name it wrong task. Let's say, sorry, I'll make this capital, wrong task, and this will also inherit from our parent task. Okay, I'll just copy this code and I'll change the constructor to wrong task. See, we have get description here. Instead, what I will add is completed. Okay, I'll copy this function and I'll rewrite it in our this class, this new wrong class. And instead, see this function, what is it responsible for? See, our base class says that is completed means that it should able to make a task status as completed, right? Is the meaning of this function. But instead what I did is I overwrite it. I have overwrite it with, let's say, something with a string. Task completed. See, now this violates, oh sorry, so this violates the Liskov principle. You know why? Now whenever you do is complete here for your task, it will give an output. Instead of marking it as complete, it will just output this text. But in general, or in reality, is completed function was responsible to change the status. But what you did is, while creating a subclass, you change the functionality of this class. Now will it be able to substitute the base class completely when you write the code? No, right? So let's see an example of what this will output. See, please don't get confused. Right now this urgent task completely is able to substitute our task, right? So you can see the output is almost the same. If you change the task one that completed, make it completed, it will come complete here, it will come complete here. Let's see. Okay, I'll just write the code to make it redundant. So ts task dot, sorry, index I'll give 0 dot is completed, and I'll just complete this. Okay, and 1. See, now look at this very carefully. Okay, I have given is completed function to both of the tasks that I added. So if I run this, you'll get a similar result. See, same way, complete. If you just comment this out again, same way, one is incomplete, one is complete. Okay, but now this is like, no matter whatever you use, like task or urgent task, the way of this to function is the same. But instead, what I'll do is, now I'll add a task dot push back our new wrong class, wrong task. I say LSP I'll do this. Now this is able to replace our base class or not. Let's see. So it will not be wrong because this memory is also going to take the wrong task as well, because this is also child of the same base class, right? So we are not expecting an error, we are just expecting a unusual behavior, and the unusual behavior is coming from where? Not from the device, but not from the system, but from ourselves, because we have written it wrong. We have not followed this principle. So if I allow, see, now we have everything is working fine. Incomplete, complete, incomplete, right? So right now if I make our second one, which is this one as is complete, because we have changed the function, right? Right now we did it intentionally, but if you didn't know about this principle, you have done it without any intention, right? You would have thought like, I will just change the function, it will work, right? I want to change it, but this completely violates the principle. So understand this. If you wanted to ever do or change the function, do it, create a separate class, work on a separate way, or create a different function, but don't violate the principle. Right now if I do is complete, now this will work in completely unexpected way. See, now I have task completed, even though I have said like make it complete, task 2 is complete. Now it's still getting what? LSP violated is incomplete. See, I'm getting unexpected result or not? I'm getting this output, which makes no sense to this system. For the user, it doesn't make any sense. And as a developer, I made this mistake, and this is a design mistake, not a code mistake. It's not an error. It is just working on an unexpected way, right? So I said clearly in here that make it complete. I still have this status incomplete, but I'm getting this console value as task completed. This doesn't align with our system. So this means that this wrong task is not completely able to substitute our base class. Like, see, both of these, even if you change the status, it completely changes the status. It doesn't behave in a unexpected way, but this did, right? So this is what LSP principle is, and write your code so that it doesn't violate this principle. Okay, see, and it's very easy, right? I hope you guys are not confused. It might get a bit confused, it might get a bit confusing if you read the articles or if you go through it on the website or any other tutorial pages, but right now I'm showing you the example, so I think it is getting a bit clearer for you. But if you have any confusion, please ask me in the comments. I'm very happy to help you guys. Thank you so much.